Okay, let's move on to Climate Mitigation Working Group 3, which is mitigation of climate change. I'm obviously again going to focus on the summary for policymakers because these documents are thousands of pages long, and I'm not going to include all those details in an introduction here. I have already talked about net zero in many podcasts because it's a very focused target now for many groups, including International Energy Agency, International Renewable Energy Agency, and McKinsey, and so on and so forth. We do visit net zero here a little bit, but this is remembering that IPCC AR6 is a concerted exercise to synthesize all the literature plus do some simulations for the future, especially in this case with integrated assessment models which have their own details that we are not going to get into. So keeping all that in mind, let's start with the basics. Global net anthropogenic emissions have continued to rise across all major groups of greenhouse gases, which we already have talked about a lot. And since 1990 was kind of the tipping point for deciding that global warming was real and international negotiations and agreements have to be accomplished, and historical responsibility was dealt with in various ways. That becomes the good starting point, becomes a good starting point for these discussions. So we are looking here at 1990 to 2019 when the report was finalized. Obviously things have evolved since because of the pandemic, the slowdown, drop in greenhouse gas emissions, and then the rapid ramp up and so on. So lots of issues happened since, a lot of interesting things happened after that, which actually give us a good metaphor for how humanity struggles with climate action, especially the Russian invasion of Ukraine as well. So whenever there is a crisis, climate action can take a back seat. We have to keep that in mind as well in the context of these global warming targets. So here are greenhouse gas emissions in gigaton CO2 equivalent per year, again converting non-CO2 greenhouse gases into CO2 using concentrations, global warming potential, and so on. Global net anthropogenic GHG emissions over 1990 to 2019. We are looking here at fluorinated gases, CFCs, HFCs, nitrous oxide coming a lot from agriculture, very potent greenhouse gas, methane 25 times more potent than CO2, and net CO2 comes from land use change and forestry, so LUCF, and CO2 from fossil fuel and industry. And we are looking at the totals here. We will look region by region as well. So we started here at 38 gigaton CO2 equivalent per year in 1990, and you can see the various rates of increase. CO2 from fossil fuel and industries has now gone up to 64% of the total, and the net CO2 from land use is gone up to 11%, started with 13%, so it has in fact reduced a little. Methane is now 18%, started at 21%. Methane is a difficult one to explain even in terms of its trends, but there is a new treaty to reduce methane emissions by 2030, which is good news, of course. And there are fluorinated gases and nitrous oxide there as well. So we have gone from 38 gigaton CO2 equivalent per year to 59 gigaton CO2 equivalent per year in 2019. And looking at 2019 more specifically here, you can see the uncertainties in the estimates of CO2 from fossil fuel and industry, net CO2 from land use change has a huge uncertainty there. Methane and nitrous oxide as well as fluorinated gases. So looking at global anthropogenic greenhouse gas emissions and uncertainties by gas relative to 1990, this way it tells you a little bit more about how uncertain the estimates are. So greenhouse gas emissions in percentages, CO2 FFI has gone from almost 100% to now more than 150%. So these are emissions and uncertainties relative to 1990, how much it has increased in terms of the percentage change. CO2 from land use, you can see there is a large uncertainty range, very non-uniform, very local, hard to monitor, and so on. Methane has a large bit of uncertainty as well, but this may have remained flat or even decreased a little. This has increased a little bit. N2O has increased, but again, large range, very small concentrations, but very potent in global warming potential, and flue gases have increased quite a bit in terms of percentages. Okay, so if we look at 2019 emissions in again gigaton CO2 equivalent and 1990 to 2019 increase, and emissions in 2019 relative to 1990. These are the numbers being summarized here. CO2 from the two are where in 2019 at 38 plus minus 3 and 6.6 plus minus 4.6, so the range is quite large, as you can see. Increase in gigaton CO2 equivalent here, 15 and 1.6 respectively, but the percentages are telling 167% and 133%, and similarly for methane 129% and 133%, flue gases, fluorinated gases 354%, and the total is 154%. This is quite disconcerting in terms of the global warming targets and where we need to be. But if we look at emissions across the regions, they have grown in most regions, but the distribution remains uneven in the present day as well as cumulatively since the Industrial Revolution, which we always refer to as 1850. Because that's where the good data starts. Global net anthropogenic greenhouse gas emissions by regions 1990 to 2019. You can see again the total increases for the globe and gigaton CO2 equivalent per year of all greenhouse gases. So here again the same legends we used before. So international shipping and aviation is adding 2% right now, disproportionate in terms of its contribution per capita. For example, if you fly, you can wipe out your entire year's carbon footprint in other things, for example. Australia, Japan, New Zealand, Middle East. So Eastern Asia has had a significant increase since 1990, went from 13% now to 27%. India and China booming economically and increasing. Actually, Southern Asia is here, so I should be careful. Eastern Asia is China, Japan, and so on. North America remains from 18% to 12%, so energy intensity of the GDP and carbon intensity of the energy have improved over Europe as well as North America. You can see that here, but per capita carbon footprint remains high. So just keep these in mind for where we are going in terms of the discussions. So historical cumulative net anthropogenic CO2 emissions per region. North America remains high. Somewhere in the CO2 emissions in gigaton CO2. So it is historical cumulative net anthropogenic CO2 emissions. Again, remembering CO2 from land use and from fossil fuel and industries. So Europe is up there, Eastern Asia, Latin America and the Caribbean, Southeast Asia and Pacific land use change is large here. And South Asia is down here, not as large as Eastern Asia, for example. Middle East, international shipping and aviation. There are many details, right? So Middle East, what is emitted locally and what is embedded in the oil that's exported, which is burned elsewhere. We don't want to get into those sorts of details. Nonetheless, net anthropogenic greenhouse gas emissions per capita and for total population per region in 2019 alone. So North America has a high footprint here, but you can see the population is modulated. So this is CO2 from fossil fuel and industries. Land use change is negative here, positive in other places, and other greenhouse gases here. For example, Eastern Asia has lower per capita footprint but has a large population. Southern Asia, for example, has relatively low carbon footprint but a fairly large population. So the area under the curve can still be smaller for this country, for example. But again, the thing to remember is that as middle class grows and economy develops, here per capita may not have much meaning because they were averaging over a large population, with the top 10% or maybe 1% living with these Western style footprints, but the poor living with a very small footprint. So the average doesn't tell you the whole story in terms of the trajectory where they are going. So as economies grow, consumption grows, per capita emissions grow. Of course, good news is that both China and India also have flattened their energy intensity of the GDP and carbon intensity of the energy. So I'm going to stop this podcast here, and we'll continue the other details into next podcast. But you get the idea that greenhouse gas emissions are growing everywhere, but not at the same rate. Plus, cumulative emissions also have grown differently over different regions, which is important when we think about future actions and equal but differentiated responsibilities in dealing with climate action. Okay.